two separate things, because it's really, they really work hand in hand. This is kind of blurry. Yeah, sorry about that. I don't know if I can get it any better. I'm gonna email you guys this PowerPoint at the end of this, but this is a chart that shows the foundation facts, and so you will start with understanding that +1 is one more, so that number line sense, counting up 1, counting up 2 more, so the +1 and +2, +0, +10. They've been working a lot on this as far as using hundreds charts and seeing 10 more, obviously counting by 10s, they've been doing that. Doubles, making 10, and then these skills down here, they build off of these initial foundation facts. Anything you want to add? I'm not, okay. I kind of put this in here just for your information for future, and I know Amanda can speak to extra math that they're using right now in 2nd and 3rd grade, and it's just fact practice. We like it because A, it's free, and B, it reports back to the teacher what was missed, how long it took, and such. It's easy practice they can do at home. Khan Academy is what's being done in the summer for 2nd going into 3rd, and then through 8th grade. And so obviously that doesn't affect you guys this year, but they're also using it, some teachers are using it through the year too. It's a review of concepts, but it can also, it's a great way to differentiate, move, kids on, and it has videos so they can do independent learning as well. And we do plan to continue to use that. And we think it's important that, they're doing summer reading. They also need to be doing summer math. It's really distressing how much is lost over the summer when it's not used. And then ScoopPad is being used in 3rd and 4th grade this year, and it's another one that's really good for differentiation. It has a placement test, and then the teacher can also choose topics that they either want a child to have more reinforcement with. Maybe there's a gap from something in 2nd grade that they still need more practice with. Maybe they're several grades above, and a teacher can go in and assign, make assignments and such, and the child shows their work on the screen, and then the teacher, when they go back and see what they've missed, they can actually see where they made the mistake. And so I'm trying to think.
So we have, in the past, 1st grade has done extra math, more towards around winter break and on, practice math facts. You can also see, it's a great way for extra practice. This year, though, we've talked about looking into ScoopPad. That's something over the summer we were looking into. We found out 3rd grade has a license for it. So we are going to be looking into that. Right now, that's because of the differentiation part, and it's a little more than just facts. Because yes, that's great to have. Some kids are already mastered their facts, and they need something a little bit more. So that's something, because it is, we're looking into seeing how age appropriate is for 1st grade, because they don't do it until 3rd grade, but I think they do have a first grade age. So right now, teachers we're kind of exploring ourselves and seeing our thoughts about that, and then we will put out there when we made that final decision to probably do extra math as well, just for fact practice. And it's free, it's a great way.
ScoopPad does not have fact practice yet. So there would need to be a separate fact practice of some sort. Yes. Okay, so the next thing I want to talk about is addition and subtraction, and I want you to see how your child is going to be taught. This is one of the ways. There's strategy, they'll be using the number line to really emphasize that it's that numbers and adding and subtracting is linear, And, but this is another way that we use base 10 blocks. They look like such, this is a ones, this is a tens round, and this is a hundreds flat. And just so you know, they haven't really done much with these this year, so just keep that in mind when you're watching the video. Listen to the language. It's important to talk about as they're manipulating the pieces, what is the value of that piece that you're putting there, and what does that represent? Okay, and we did not do any with renaming, and that's another word for carrying, but obviously there are students that are ready for that, and we'll be doing that this year.
Okay, remember what is your additional problem? Very good. Lauren, you will be first on Mark.
And this is
And what number did you build? Very good. And what are you going to do next?
She said at 4 is what she said.
And she's separating the group so she can go back and make sure she added the correct amount.
Which is that, separated, they
Just so they can double check.
What number did you just build?
She pushes them together.
No, she counted by 10.
She is counting by 10, so she in her head was going 10, 20, 30, 40.
Very good. How many tens are in the number 77? How many 10 dots do you have in the number 77? Very good. How many ones do you have in the number 77? Very good.
Okay, and then you'll see we'll move from concrete to pictorial where they'll draw it, and eventually they'll circle the groups of 10 and show how they're taking it over to the tens place, and so that's really important for them to visualize it. And then from concrete and pictorial, we move to symbolic, and that's also referred to as the algorithm. It is so important that they have these foundational pieces before they are taught the algorithm, because otherwise all this is procedures, is steps, is because they told me I'm supposed to bring this up here and then this comes down. It doesn't have meaning. And that is what we want to make sure does not happen. We want to have meaning with it. There are kids, I will say, multiplication, I'll get them and they'll already know the algorithm, and we'll have to go back and decompose it, and I'll say, you can't use that until you explain to me what the heck is going on there. And in order for them to know what's going on, they have to really have a sense of place value and number sense, and we break it apart, and then they can see the relationship between the algorithm and the true value of the pieces and what's happening. Does that kind of make sense? Okay.
And like Kathleen was saying, some kids are going to differentiate by some kids are still only working in this one's house. They're adding 1-digit numbers together using the cubes. Other kids are doing 2 digits, some are regrouping, some are in 3. So it just depends on, like she said, they truly have it and can show it and know how to explain it, then we do differentiate with it.
Right, absolutely. We are constantly meeting them where they're at and moving them on. That's our goal. It's not a race by any means, and we're definitely using problem solving. This is computation, but then you have to take that and put it into a real world situation and see what they do with it and if they're able to manipulate it the same way. Okay, so then in subtraction, I'll go ahead and show this video.
Okay, Kyle, go ahead and tell tell us what our math problem says. Very good, and what are you going to do first? How many tens? How many 10 rods? 5. Very good, go ahead and build it. So you got how many 10 rods? And what are you going to do next? Okay, do that. Is that the first one that you built?
And in subtraction, they just build the total. They just build the one number, and then they're gonna take away from that. A lot of them tend to wanna build both numbers and then try to manipulate.
So what's your number right there? Your basket? Very good. And then
And
what
he
is-
is checking to see if it matches what was given.
So you realize he has to take 3 tens and 1 1.
And again, we have them put it underneath the mat so they can check it in case they make a mistake about how many they take.
And I will emphasize, and this, for some of your kids, this won't come till later, but when they do get into a situation where there is renaming, we want to make sure we use the term renaming, not borrowing. Borrowing insinuates you're giving it back and you're not. You're renaming it, and so if we have 23 minus 14, I'm going to name this. It still has a value of 23. I'm just going to name it something different. It is now 13 ones and 1 10. It's still, and we emphasize to the kids that it has 2 10s and 3 ones has the same value as 1 10 and 13 ones. But the other thing is, I want you to make sure that if your kids say, well, I can't take 3 minus 4. I want them to understand, we want them to understand that you can take 4 away from 3. But what's going to happen, and you draw a number line for them, help them visualize it, let them know that there are numbers on the other side of 0, okay? Because it's almost like we lie to them, and then later on they're like, wait a minute, and I understand that we just need to get away from this, so they can't understand that yet, because a lot of them can't. I mean, it will blow you away. So we're at 3, and we show them when we do 4 jumps, oh my gosh, we ended up on the other side of 0. It's a negative number. We don't want to deal with negative numbers right now. So to make it easier on us, we are going to go over to our 10s and get some more 1s. That's the kind of dialogue or discussion I would encourage you to have when you're doing that with your child. Do you have any-
And again, this is just one tool that we use. Some students may use Unifix cubes. Again, we can make towers of 10 and use those Unifix cubes. And we use as many different concrete materials as we can because it just gives them multiple ways to show how they solve these problems.
You heard us spoke about this a little bit before, and this starts in kindergarten, first grade, and they'll use it all the way to 4th. It's understanding part, and whole, and figuring out where in the problem, what's missing in the problem, what do we have or we know what's missing, and this visual of, Connie has 8 red marbles and 13 blue. Well, how many does she have? Well, we would ask the kids, a lot of times we will give them this visual with nothing in here. And we'll say, well, what do you know? Do you know the parts? Do you know the total? And they'll fill in, well, I know 8 and 8, and then as you see in the visual, you put those together and it makes the whole. In a different type of problem, she has 21 marbles, 8 are red and the rest are blue. You can see how they have the whole or the total, and they have a part. Well, how are we going to find that other missing part? Otherwise, they're just guessing. Well, I'm just going to add these. I'm just going to subtract these. There's no reasoning. It ends up not being reasonable. And so this visual is really important, and you can see how it will move into, some pre-algebra skills later down the road. They put boxes in first grade, but really, we start putting letters because it's the same thing. And why not expose them to that, if they're ready for it. And so you can see how, here, a lot of times they'll want to say, I'll just add 33 and 25, and they'll put the answer down, and I'll write on their homework, is this reasonable? They didn't think about, well, what am I starting with? I already know my total. I already know my total, and I know one of my parts, so what do I need to do with these to figure out the other missing part?
And we teach this, when we teach this, we purposely mix up different problems. We don't do all the same problems because what they didn't do
They
that.
catch on
They just wrote, try and add the two numbers every time. So we do interchange them and mix them up and say, like she said, talk through that with them. What do we know? That's tricky. It's a tricky
It is
concept.
And it's developmentally it should be, and for several years, it's an ongoing, you'll see that, and it'll get more difficult as they go along.